Good morning everyone. Today I will present the statistical analysis of life insurance dataset containing information from 1,338 individuals. So this dataset includes 7 variables, which is age, gender, BMI, number of children, smoker status, region, and insurance charges. For age, BMI, number of children, and charges are quantitative variable, while gender, smoker status, and regions are qualitative variable. For descriptive statistics are used to summarize and understand the data through numerical measures and visualization. Inferential statistics such as hypothesis testing, independent sample t-test, and ANOVA help determine whether significant difference exists between groups. The purpose of this analysis is to identify how demographic and lifestyle factors influence insurance charges. This finding can help insurance companies make better decisions, improve policy planning, and assess risk more effectively.
Thank you, Ikim, for the wonderful introduction. Assalamualaikum and very good day to Dr. Madia and everyone. My name is Nur Hidayah and today I will walk you through Chapter 2.0, which focus on our sampling data selection process. To begin with, our original data set is quite massive, consisting of a total of 1,338 individual observations regarding life insurance premium rates. According to our assignment guidelines, every group must extract a completely unique and randomized subset of samples so that our data is tailored specifically to our group. To achieve this customized sample, we extract to the last 2 digits from the metric numbers of all 5 group members. As you can see on the slide, the extract pairs of 06 from Atira, 45 from Hanis, 50 from Ikin, 51 from myself, and 74 from Fatiha. From this specific series of numbers, we carefully identify our 2 critical boundaries values. Our smallest number is 06 and our largest number is 74. Next, we apply this value directly into the required assignment formulas. The formula for the exact number of cases is 500 minus the smallest number, which gives exactly 494 cases. The formula of our target range is 500 plus the largest numbers, which means we must select these cases from the first 574 cases of the original dataset. Therefore, our ultimate sampling action for the group 19 is to randomly select exactly 494 observations out of the first 574 observations. Now let us move on how to execute the systematically using software. Now that we have our exact mathematical parameters, we transfer this logic into IBM SPSS statistic to execute the data extraction. We did not just guess the numbers. We strictly follow a 4-step technical process to maintain data integrity. First, after loading the complete insurance dataset into the SPSS software, we access the primary selection menu. We did this by navigating to the top menu bar, clicking on data and then selecting select cases at the bottom of the drop-down. This action immediately opened up our primary dialog box. Within this window, under the select region, we tick the option for the random sample of cases. Second, we click on the sample button up to open up the sub-dialog box where we could apply our unique metric formula. Here, we select the exactly option and key in our precise group parameters. We command SPSS to filter out exactly 494 cases from the first 574 cases, matching our manual calculation perfectly. Third, after clicking continue to go back to the main menu, we had to configure our output action. This step is incredibly important. Under this output section at the bottom, we strictly select the option titled Delete Unselect Cases By doing this, we permanently eliminate the remaining unselected row from our active working sheet, ensuring that our final dataset will only contain our distinct group sample without any mixed data. Let's look at the final outcome on the next slide. This brings us to our final verification phase. Once we click the OK button in the dialog box, the SPSS processor instantly executes our command and update our active data view sheet. As you can clearly see in figure 2.4 on the slide, the data row immediately dropped the original 1338 observation all the way down to exactly 494 observation. This proved that our random selection process was completely successful and seamless. We double-checked the data structure, ensured there were no missing value and or error, and saved this modified file as a brand new dataset. This specific file containing our 494 unique sample is what our group used as the solid foundation for our subsequent analysis. This completes our sampling steps, and we are fully ready to explore the actual business inside of the data. To explain what this 494 policyholders look like in terms of numbers, genders, and smoking habits, I will now pass the presentation to Tira for the descriptive statistic analysis. Thank you.
Hi, Assalamualaikum to the doctor and everyone. My name is Atira binti Abdullah, and okay, next we move to 3.0, which is descriptive statistic. Today, I will be presenting about the descriptive statistic. Based on the table given, this analysis was conducted using a sample of 494 respondents. The purpose of this descriptive statistic is to summarize and describe the main characteristic of the data before conducting further statistical tests. First, for the age, the mean age of the respondent is around 39 years old, with age ranging from 18 to 64 years old. This shows that the sample consists of adults from various age groups. Next, for the BMI, the average of BMI is 30.78, with values ranging from 15.69 to 49.06, which is the relatively small standard deviation indicate that the most BMI values are clustered around the average. Next, for the insurance charge, the mean annual charge is about 13,100, while the median is about 9,421, and the large difference between this mean and median suggests that some individuals have exceptionally high insurance costs, which is the charge range from 1,100 to about 63,700, showing a wide variation among the policyholder. Next, for the categorical variables, females represent 51% of the sample, which males represent 49%, that indicates a balanced gender distribution. Next, we're moving on to the graphical representation on the pie chart that clearly show that the majority of our respondents are non-smoker, meanwhile the histogram of our insurance charge is positively skewed. This is meaning that the most respondents have a lower insurance charge, while only a small number of individuals incur very high charge. So, in conclusion, the descriptive analysis shows that insurance charge vary considerably among the policyholder, and the majority of respondents are non-smoker. This finding provide a foundation of the inferential analysis that discussed in the next session. That's all from me. Thank you.
Hello, so we are going to hypothesis testing, so 4.1. So in this study, hypothesis testing was conducted to determine the selected factor have a significant effect on the insurance charge. So hypothesis testing help us decide whether the different observed in the data are statistically significant or occur by change. So two certification tests were used. The first one is the independent sample t-test was conducted
to examine whether there is a significant difference in insurance charge between smoker and non-smoker. So second is the way ANOVA was used to determine whether insurance charge different significantly across different regions. So for both tests, the significance level was set at the 0.05. If the p-value is less than 0.05, the null hypothesis is rejected. So indicating a significant difference exists. So however, if the p value is greater than 0.05, the null hypothesis cannot be rejected. So meaning there is a sufficient evidence to conclude that the a significant difference exists. So therefore, there is a test help identify whether a smoking status and region are important factors influencing insurance charge. So that's all about 4.1. Okay, next we are going to 4.2 is one of the tests that we can do in this assignment. So the one is this independent sample t-test. So independent sample t-test that I explained in the 4.1 is the was conduct to compare insurance charge between smoker and non-smoker. So we can see the result in the graph that I show. So they show that non-smoker have an average charge of 8,365.29, while much more smoker has a much higher average charge of the 31,994.78. So this suggests that smokers tend to pay substantially higher insurance charge. So the t-test results show the p-value of the less than 0.01, which is lower than the significant level of the 0.05. So therefore, the null hypothesis was rejected. So this indicated that there is a statistically significant difference in insurance charge between smoker and non-smoker. So in addition, the cohort D value was 3.009, indicating a very large effect size. So in conclusion, smoking status has a significant impact on the insurance charge, and the smoker generally pay much higher insurance charge than non-smoker. So that's all the 4.2.
Next, I will present the results for the analysis of variance or ANOVA. ANOVA is a statistical method used to determine whether there are significant differences in mean insurance charge across different regions. In this study, we examine whether the residential region of an individual has a significant effect on the amount of insurance charge paid. For this ANOVA test, the hypotheses are as follows. The null hypothesis states that there is no significant difference in mean insurance charge among the four regions. The alternative hypothesis states that at least one region has a significantly different mean insurance charge. The level of significance used in this study is 0.05. Before conducting the ANOVA test, we first examine the mean insurance charge for each region. The Northeast region recorded a mean charge of 13,340 ringgit and 48 cents. The Northwest region recorded 12,507 ringgit and 21 cents. The Southeast region recorded 13,435 ringgit and 85 cents, while the Southwest region recorded 13,054 ringgit and 57 cents. Although there are slight differences in the mean values, these differences appear relatively small. Therefore, a statistical test is required to determine whether the differences are statistically significant. Before interpreting the ANOVA results, we check the assumption of homogeneity of variance using Levin's test. The test produced a p-value of 0.434. Since the p-value is greater than 0.05, the assumption of equal variances is satisfied. Therefore, the ANOVA results can be interpreted confidently. The ANOVA test produced an f-value of 0.149 and a p-value of 0.930. Since the p-value of 0.930 is greater than the significance level of 0.05, we fail to reject the null hypothesis. This indicates that there is no statistically significant difference in mean insurance charge among the 4 regions. In conclusion, although the mean insurance charge varies slightly across the Northeast, Northwest, Southeast and Southwest regions, the ANOVA test showed no statistically significant difference. The test produced an f-value of 0.149 and a p-value of 0.930, which is greater than 0.05. Therefore, we conclude that residential region does not significantly affect insurance charge. This suggests that where a person lives is not an important factor in determining insurance charge within this sample.
In conclusion, the statistical analysis help us understand the factors that affect life insurance charges. Descriptive statistics provide insight into each BMI and insurance costs, while graphs clearly show smokers pay much higher insurance charges than non-smokers. The three tests confirm that smoking has a significant impact on insurance costs. However, the ANOVA test showed that there is no significant difference in insurance charges across different regions. Overall, the result indicates the smoking status is a major factor influencing insurance fees, whereas region has little effect. The study demonstrates how statistical analysis can support better decision making in the insurance industry.